Hello everyone and welcome. My name is Eric Coleman with IIST and I will be the moderator for today's webinar, Improve Life Cycle SQA with Measurements by Tom Staub. We're excited you're able to join us today and set aside an hour to attend this webinar. This webinar is one in a series of free webinars to introduce the topics as well as the presenters of the upcoming SQTM conference in San Diego, California, September 13th through the 18th at the Sheraton San Diego Hotel and Marina. The conference focuses on advancing the test management and quality management professions by providing practical methods based on best practices. The ongoing theme of the conference, Practical, Proven, Feasible, keeps the focus on what works. To view the conference program and more information, visit www.qualitymanagementconference.com. Be sure to join us for the next webinar in the series, Best Practices in Project Management by Dr. Magdi Hanna, on August 7th from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to www.qualitymanagementconference.com. This webinar is being recorded and will be made available for viewing within 48 hours at www.qualitymanagementconference.com. I will now turn the webinar over to today's presenter, Tom Staub. Tom?
Thank you, Eric. I appreciate it. I'd like for you to look at this first. It's just telling you that there is copyrighted and intellectual property material in this webinar, and those laws do apply. So let's get started. First thing I think we need to talk about is what's SQA. And SQA, and a lot of people think of software quality assurance as testing. Well, in the quality profession, outside of IT, that's not what it means. QA is something different. So let's look, first of all, at what SQA means and the type of functions it performs, and go from there, and then we'll build on it and talk about measurements. So SQA Team Function is early defect detection, testing, which we all know, defect analysis, defect prevention, and process improvement, configuration management, improve quality, customer satisfaction, business value and ROI, and consulting. Well, look at those topics, and I'll bet you that a lot of you, first of all, say testing. Yep, that's it. Defect analysis. Possibly, if you have time, you analyze the defects and try to find out the root cause of it. And defect prevention and process improvement, I'd almost say those you don't normally think of in the IT profession as being a software quality assurance function. And the same goes for configuration management. So I'm throwing some new things at you of what the team function should be. So if these are the functions, how do we organize it in our organization, and what are the components? So first of all, software quality assurance should be on the same level of reporting as information technology, marketing, sales, any of the others. So it should report to the CEO, COO of the organization. And the first thing as part of this organization is configuration management. That is a quality function, which a lot of people don't think of as an SQA function. And configuration management, if you look at the definition of it, as put out by IEEE in 610-12, is a discipline applying technical, administrative direction, and surveillance to identify and document the functions and physical characteristics of a configuration item. And it controls changes to those characteristics. It records and reports change processing and implementation status, and it verifies compliance with specified requirements. That's a lot of things that are covered by CM, and organizations, if they're going to not have something, I found that a lot of times they don't have the configuration management element within their IT organization or in the development of programs. So configuration, every one of them that I've looked at and seen is a little unique, because it really, I can tell you, and I do tell you in my configuration management course, the elements that need to be in a CM program, but how you structure them, how you manage them, is usually unique to each organization. So you need to look at your CM process and make it fit your culture, your organizational culture. Why do you need it? You need it because you need the one central group to manage the configuration items, the changes, and the version control on your software and your configuration items. And the configuration items are more than what most people think of. So you need to, everything, the test plan, the test scenarios, the test scripts, those all are configuration items and should be under configuration management control. And so are the requirements, so are the design. So all of these things are part of configuration management. Can you succeed without it? Well, to a point you can. You really need CM for this controlling factor within your organization and within your IT element. So the next one is quality control. Let's look at quality control and try to relate that to the IT profession. Right now, most organizations are calling testing quality assurance. It's not. If you look at a manufacturing operation, and let's take the production of a car. A car has quality control stations throughout the production process, and these are inspections that go on at that particular quality control station. Well, if you look at testing and think of it as this quality control function, it focuses on products. Its goal is the defect detection. Some of the common QC functions are test planning, software testing, reviews, inspections, checklists, and verification and validation. So you see, all of those functions are what we consider part of the testing process. And they're truly QC functions, because if you equate them back to the manufacturing methodology and process, which is where all of our quality functions started out and originated, they all relate to QC. So where we're now calling testing quality assurance, it should truly be called quality control. So here's quality assurance. Well, if quality assurance that we're calling now is really quality control or testing, well, what's part of the quality assurance function in this software quality assurance organization? So their primary focus is on defining, deploying, continuously improving. Goal is defect prevention. Well, see how that is different than the quality control function, because their function is on defect detection. Ours is in quality assurance is on defect prevention. So what are some of the functions of quality assurance? They're auditors. And I'm going to show you a little bit in the life cycle what I'm talking about here. They're facilitators, they're educators, they're quality planners, they're analysts, and they do measurements. And they analyze measurements and metrics. So this quality assurance function, as you can see by the functions they perform, is totally different than quality control or testing. And what do I mean by facilitators and educator? Well, when I was working in quality assurance, I had an organization come up to me a lot of times. Once we'd got the quality mindset within the organization to where they were thinking, yes, we need to put out a quality product, they would come up to me before they changed their process and they said, well, Tom, I want to do so-and-so. Will this still fit within the quality function that we're trying and the quality mindset that we're trying to work on here and to accomplish? Most of the time I could go, yeah, that's going to work. It's going to still give you the quality product and the measurements that you need and you want to do your job. But sometimes I'd go, well, wait a minute, tell me why you want to do this, because what you're proposing is not going to accomplish, not going to be what we need. So they would go in and explain why they were wanting to do something. Well, when I did that, then we could work on, okay, let's solve this dilemma to where it helps you and still puts out a quality product. So that is in the quality facilitator, educator, and planning element of this. So that is what you, if you're in the quality assurance function, that's what you're going to be doing. Now, most of the quality assurance function is truly a staff function. And so most of the time when I present this course as a one-day or two-day course, the first question I get is, well, what's the difference between a line and a staff function? Well, most companies are set up in a line and staff organization. They may not realize it, they may not call it that, but they are. And when we get into this, you're going to see what I'm talking about. The term comes from military. And so in the military, they've got a line function and they've got a staff function. Well, the staff functions are the support function. And quality assurance is a staff function. They don't contribute to the organization core work of production, sales, marketing. So you can see that these three elements bring in money. They are the core work of the organization. Everything else, which is a staff function, supports the organization with specialized advisory or support functions. And one of those functions is human resources, accounting, public relations, legal, and quality assurance. So you see how SQA fits into the support organization. Now, IT, I've had a lot of people, when we get into this discussion of line and staff, they go, well, IT is a line function. I've heard the argument made that yes, it's a line function because it supports the core function of the organization. And it advances it. But then I get the argument that no, wait a minute, it's a support function because everything it puts out supports the organization. So I'm going to let you all have that argument within your organization, but just know that for our purposes, quality assurance, or SQA, is a staff function. And they offer advice in an effort to improve operations. You're offering advice in all three functions: configuration management, quality control, and quality assurance, to improve the operation. If you look at it on an organization chart, if the organization chart was drawn correctly, and most of them are not drawn this way, but you can see that software quality assurance, the dotted line means that's the communications line, that's the support line, and they support information technology, marketing, sales, and the CEO and COO. So I told you that we were going to look at the life cycle and see how all three of these functions fit in. Well, I'm using the V model. So you may be using something else, but this is the easiest one for me or for most people to understand. So the first thing is the boxes that are in the blue-green, let's say, color are that's the steps that we're going to take. Well, quality control or testing is involved in the system's requirement specifications, because your job at that point is to say, no, that's not testable, or yes, it is. And at that point also, you're looking at, you're going to be doing inspections. You're going to be checking to see whether we have any defects in our requirements. Well, the systems requirements review, that's supposedly done by the signers. But what I find happens when we set the organization up the way I've proposed is that quality assurance goes in there and does an audit. And they go in and see, okay, how many defects were found, how many were cleared, are there requirements of is the team that's developing the requirements, have they signed off? Is everything ready to go And if it is, they submit a report to the reviewers, and what the reviewers go, okay, and they sign off. So that's another step, but it's a step that needs to be performed, and quality assurance does it. Well, once those requirements are approved and frozen, they go into the control library in the CM control library, and a working copy is checked out for the next process, which is design. Well, again, quality control testing gets involved in the design. While they're going through it, they do inspections, they do reviews, they record defects, they show that they've been corrected, and again, at the preliminary design review, or you can just have one design review, whatever your organization does, quality assurance comes in, does the audit, makes sure that everything is ready to go, and writes the report, sends it to the approving authorities. They sign off, and it's approved, frozen, and goes into the control library. So the process continues in this way throughout the life cycle. Now, keys to successful measurements. We need to establish the right measures. If we don't have the right measures, we're just wasting our time. We have to give timely feedback to the stakeholders that are interested in this process or in this systems that we're developing. And we need to analyze the data. We're pretty good. We're very good, in fact, about collecting data and measures, but the analyzation, that a lot of times falls through the cracks. So in order to be successful with our measures, we have to have analysis of that data. So why do we measure? Well, we do status updates. That everybody wants to know, well, where are you? What are you doing? How successful are we? Historical data for analysis. Well, at some point, you're going to wind up having to do analysis. Either something is going to go wrong or something is going to trigger the analysis. So you have to have that historical data. Improve the processes. I met with one company, and their CEO decided that, rightly so, he was tired of the IT not producing systems on time and on budget. So he says, I want to improve that over the next 5 years. So come up with a new process for doing it. Well, they went back and looked at the historical data that they had, and it wasn't the best, but the best they could come up with was historically they were only producing less than 50% of their systems on time and on budget. So they said, okay, within 5 years, we want to produce systems that are 90% of our systems we want to produce on time and on budget. Well, what they had to do was then go and figure out and change the process of how they were doing things, which meant the quality is going to be affected. The quality of the product was, so we want to do it on time and on budget, but we don't want to degrade the quality of the product. We wanted our customers to be satisfied with our product. We wanted to give them the product they were expecting. We wanted to improve our business value, and if we started delivering systems, 90% of the systems on time and on budget, we were going to improve the business value, and we were also going to save money because we weren't going to be constantly having these cost overruns. We want to control. We want to do self-assessments. We want to continuously improvement. So we want this continuous improvement, and you can't improve the process unless you know where you are. You have to have a baseline, so you have to do the self-assessments to know where you are. And management assessment. Remember that the data that you collect and you publish out there is going to be viewed by management. They want to know what's going on. So measures should be capable of predicting process and product parameters and not just describing them. Yeah, anybody can describe what's going on, but the prediction of the process and product parameters is something that only measures can help you extrapolate. They should be simple and precisely definable. They should be objective, easily obtained at a reasonable cost. It's not going to help if it costs you a lot of money to get these measurements, because you're not going to get the return on investment. So you need to figure out how do you easily obtain these measures at a reasonable cost. They've got to be valid. The worst thing that can happen is somebody calls you on your figures and you go, whoops, you're right. They're not right. So you've got to make sure they're valid from the get-go, and they need to be robust. What do I mean by robust? You have got to get as many measures and measure as many things as you can within this easily obtainable, reasonable cost and valid parameters. Before you being approved for the use, subject your measures to the following tests. They need to be reliable. So you need to have consistency of the measures. You can't measure something one way today and another way tomorrow. They have got to be measured the same way every time. They've got to be valid. I told you that they had to be valid. They have to be easily used and simple. So that's how we're capturing them within our easily obtainable and a reasonable cost. They've got to be timely. It doesn't help to collect data and hold it for a week or 2 weeks. It's got to be real time. I can tell you right now, your clients, your stakeholders are not going to be happy with anything that's not almost real time. You've got to recalibrate these measures periodically. Just like any instrument has to be recalculated periodically, your measures have to be recalibrated. What do I mean by that? What you've got going now may not be a good measure 6 to 12 months from now, because the process may have changed. And if you don't change your measures to keep up with the process changes, you're going to have invalid data. So you need to recalibrate. You need to look at your measures on a periodic basis. So the measures, the benefits of them are to show status, help to understand the process, ensure decisions are based on fact. This is an important one because what I have found, I've got a team that we go in and do assessments, independent assessments for companies. And people think they know what the problems are. And in fact, they may have actually tried to solve the quote-unquote problem. But what it comes down to is that they are really solving symptoms. They're not solving the underlying problem because they weren't making their decisions based on fact. They were making it on intuition and what they thought they saw happening. But when you dig into the facts, then you find out, oh, that's just a symptom. Show where improvements are needed. Show if improvements actually happened. So if you say we need to do this to improve the process and so get a better ROI out of the whole thing, then you need to show those improvements really did happen. And you need to show that, yeah, it really solved the problem, or no, it didn't. We still need to tweak it. So that's what statistics and measurements really do, and they reveal problems. If you will look at and be aware of what those measures are really telling you, they're going to reveal all kinds of problems to you, and that's why you need to analyze them. It doesn't help to just collect the data in the measures. You have to analyze it in order to find out what the real problems are. So people a lot of times confuse the terms metric and measures. Let's solve that problem right now. So what's a metric? It's a quantitative measure of the degree to which a system, component, or process possesses a given attribute. So measures are the basis for metrics. And a metric, you're going to take the raw data and you're going to manipulate it. And what you're going to do is you're going to say, present it as percentages or a chart of some kind. In other words, you're going to take the measures and turn them into metrics. So what types of measures are we dealing with in the SQA process arena? Well, we're looking at business measures, first of all. And we tend to forget business measures. But you can't forget them, because if you forget them, you're shooting yourself in the foot. And you've got to show management what they want to know, and in doing that, you're proving your worth. You're basically keeping yourself in business. So you can't forget those business measures. You've got organizational measures. Well, Tom, what's the difference between organizational measures and business measures? Well, we're going to talk in a little bit about a common language. And this hopefully will help you understand the difference between an organizational measure and a business measure. You've got project measures. We're aware of that. Okay, what's a project doing? Testing measures. Okay, how are we doing in our testing? And quality. What's the quality of the end product? What is the quality of the requirements? What's the quality of the design? What's the quality of the code? Now, I promised you that we were going to talk about common language. Lower management or non-supervisors, they have a language of things. And the things are requirements. The things are coding. The things are design. These are things. So they think of things in terms of things. That's the organizational measures that you're going to be looking at. Well, the next one is middle management. And I've heard people say, and I believe it, that middle management is the hardest level in an organization. So they must be bilingual. They must be able to talk to the lower management or non-supervisors in the language of things. But they also must be able to talk the language of upper management, which is money. And you always got to remember that the root of all of this is money. In any organization, money is the root. You have to keep that in mind when you're thinking of the measures and what you're looking at. So what are some of the common management metrics or measures? Well, first of all is on-time delivery, on-budget delivery. Remember I told you money is the root. Money is the common factor here. So all this on-budget delivery is one of the things you're going to be definitely want to be capturing. On-time delivery. On-time delivery equates to money. Because if you're on time, you don't have cost overruns, you're not factoring it out, just stretching the schedule or cutting testing. It is money. Return, so you've got, with these two, return on investment. It's improving your business value, because the business value, the value to your business, is impacted by on-time, on-budget delivery. Customer satisfaction, they're happy, because if you deliver them a good product that meets their requirements, meets their needs, on time and on budget, they're happy. So you've got customer satisfaction in there. And meeting business partner expectations. Remember, these systems are being developed for your business partners. So you need to meet their expectations and keep them happy. And lack of problems. Now, we're talking about this. And a friend of mine, Pat Townsend, back in the 80s, came up with a definition of true quality. And several years after his book came out, Pat and I were talking, and we were talking about his book and how it was doing and everything. And I said, well, Pat, be honest with you, I don't remember too many things about your book except for one definition. And he said, what was that? And I said, your definition of true quality. And so he says, well, what's that about? And I says, well, you said that true quality is quality of fact, which is what we're talking about here, of measurements. You can measure it, you can present it in hard facts, plus the quality of perception. Well, the perception of the quality of the product is your customers, your business partners, what they think of this system that you've developed for them. Common CM metrics is the number of configuration items that are under control, that are in the library. CIs placed in storage. How many have you placed in the library, the control library, in the last day, in the last week? Change requests submitted. So by system, by project, how many change requests have been submitted? How many have been approved? And prior approved CIs modified. So once a change request is approved, most of the time that's going to result in you going to have to go back and change requirements, design something. So if that approved request needs to have these modified, have they been modified? Problem reports submitted and solved. So after a system goes into production, you've got problem reports. So when the problem report comes in, it goes to configuration management and with a request to check out a configuration item, the latest version of the configuration item, so that they can start solving the problem. So how many have been submitted and how many have been resolved? And CIs checked out for production. So when they're submitted, then the configuration item has to be checked out for production. Common QC metrics: percentage of work done in test execution, test cases execution, defect information, test coverage, requirements, risk, code, and test milestones. So where are we with these milestones? And testing cost. Remember I said money is the root of this whole thing. So you need to put out there what the testing cost is and be able to show that you are giving a return on their investment. So common QA metrics. Are quality audits performed? How many did you perform? What were the results? Problem measures analyzed. So if you've got problem reports, is there a root cause that is causing this? Or is it a random cause? So you need to analyze those problem reports. Process improvement suggested. So if you find there's a root cause, the quality assurance organization is going to suggest improvements to correct it so it doesn't happen again. Training classes conducted. How many training classes on quality have you conducted? Quality problem consultations. I told you that when I was working quality assurance, this is a very regular thing that happened, and you need to justify your existence, and those consultations are part of the measures. So how do we present these? We present them with dashboards. A dashboard is nothing more like your car. It's a set of instruments or charts that give information. And these charts give high-level information. If you want to know what's really going on, just like if your trouble light comes on your car, check engine light, you can go and run a diagnostic and find out what's really happening. Well, the same thing happens with the dashboard. You give them a chart, and if they click on that chart, it gives them all of the background information. So what are the types of charts that you can use? You've got a pie chart. Everybody likes pie charts. A histogram, a bar chart. Well, what's the difference between a bar chart and a histogram? Well, a histogram is arranged by magnitude. So the highest to the lowest. And a bar chart just presents the data as it comes up. Cost-benefit analysis. Flow chart Everybody understands a flow chart. So use them. Spreadsheets, Excel spreadsheets, everybody uses them. So you can use them. Pareto chart, cause and effect analysis, control charts. You won't find these very often in IT, but I have used them and they're very helpful. PERT chart. So what do we tend to forget? We tend to focus on testing metrics because that's what we've been trained to do. This is what we have done in the past, so we're comfortable with it. So we tend to focus on them and forget the management metrics. We forget the QA and the CM metrics. And we don't give timely feedback. We have the data, but we don't put it out in an almost real-time version, and we don't put it out in a dashboard. So we forget to develop these dashboards, which makes presenting the data so simple, and there's enough software out there right now that it makes our job a lot easier. We collect the data in a computer usually, and there are programs out there that can take that data and turn them into a dashboard for us. And we just have to tell it what we want it to do. So, wrap up. We've covered a lot of information here, and I hope it's good information for you. We've looked at where does this SQA program, how do all of the three elements fit into a life cycle? All three have a function during the life cycle, and you need to be aware of that and work it. You need to remember that measures should be capable of predicting process and product parameters, not just describing them. You can collect all the historical data you want, but until you actually use them to describe and predict the process and product parameters, then you've wasted half of your advantage right there. They should be simple and precisely definable. They should be objective. The worst thing that can happen is if you skew the data. If you think you want it to show something and you make the data fit that, you're in trouble. It's got to be objective, and whatever the data shows is what it shows. Be willing to live with it and fix it. Easily obtainable at a reasonable cost. You can't spend more to obtain these measures than they're going to give you a return on. They've got to be valid because people are going to question your data, your measures. So you've got to be able to go back and prove they're valid. They need to be robust. So the more measures that you can collect, the better off you are. They should show status, help people understand the process, whatever that process is, whether it's configuration management, whether it's testing, whether it's quality assurance, and they need to understand the process. Ensure decisions are based on fact. So you want them to not just look at the symptoms, but the root cause. Show where improvements are needed. Show if improvements have actually happened and what they really resulted in. Did they solve the problem that we were going after? And the measure should help you reveal problems. along the way. I hope you enjoyed this. I want to remind you that we do have the conference coming up the 13th through the 18th of September in San Diego. It's one of the most gorgeous settings that there is. I was out there last year. It was a great conference. I hope to see you there. My presentation is going to be on the 13th, so I hope you attend, and I hope to see you there. If you think of any questions that were not covered in this, and after you're thinking about the slides and everything and have a question, contact me at this email address, but be sure and put in the subject line, reference this webinar. And I want to remind you that IIST is a full-service organization. We do public training, online training, on-site training, free webinars and seminars. So if you need any of these services, contact IIST at www.iist.org, and who knows, you may have me coming into your organization. So I want to turn it back over to Eric to close this out.
Thank you, Tom, for your time today, and thank you to everyone for joining us for today's free webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit www.iist.org. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day.